absolutely, Jamie. Matter of fact, one of the first projects that I saw that DCI did was a kind of a unique seismic upgrade of a medical office building where Guy and Mark came up with this funny little system of using a little piece of a wide flange. And it was kind of a really early energy dissipation system that worked pretty well. It's been in, I think it was tested in one of the earthquakes, and it did just fine. Since then, we've developed pretty good expertise. We have a number of people in the office that work not only on buildings themselves, but also working on building codes that address existing buildings and seismic upgrades. Some of the interesting projects we've done are the Crest building here in Seattle, which is on 3rd Avenue. And that was a building that was originally built back in the 20s, designed for additional stories. We started out by putting a grocery in the basement where we had to bring a lot of the building up to code. Eventually, the owner decided in kind of a mid-level that we are adding some space to it, but limited space. It's kind of, again, it was just a kind of a cool old building. The other one that I think was interesting was Centerpoint, which is a big development down in Kent, which we did some work on. And we did some analysis and found that they were a little bit questionable. I thought one thing that was very interesting is one of the buildings had some problems. It wasn't big problems, but we saw that it was a little bit torsional. And one of the things we said is this little torsional is probably going to twist in an earthquake. And the owner came back and had trouble with their budget. And he asked me, well, so what can we do to cut this out? And I showed the things we were doing in the building. One thing was putting additional frames in. And he said, what's going to happen with this building if we put additional frames? We don't put the frames in. And I thought about it a little bit, and it had some strength. And I said, well, it's probably going to be okay in an earthquake, but you're probably going to get some twisting of the building and additional movement at the corners. And what would happen then is you could lose, like, damage some glass panels and that type of thing. When we had the Nisqually earthquake back in the late 90s, that building was pretty close to the epicenter, and it went through pretty good movement, and they called us out to look at it afterwards. And we got out there, and just like I said, the corners of the building, they had a lot of glass panels that popped out. So I thought it was kind of interesting that we could foretell what would happen, but it worked well. The owner was happy. He saved some money. His loss was pretty minimal with glass, and everybody was safe in the building. The one thing I think is that if you are doing a tenant improvement to a building, we're doing changes to the interior, that's the best time to do a seismic upgrade, because a lot of the cost of a seismic upgrade is not just the new braces or the strengthening of the things we do structurally, but it's the cost of removing your finishes, doing the work, the disruption, and then coming back later and putting those finishes back in. So if we're already going to be playing for finishes and people out of the building, it's a great time to do a seismic upgrade. Thing that I think the architect could do outside of collaborating with us and talking about what we need and working into that is to really kind of try to embrace the things we'll do structurally into their upgrade. And I've done some projects where the architect actually liked having, for example, bracing in the building. A lot of architects say, oh, we don't want bracing in the shows and it goes through the windows. And people, I don't think, mind that. They actually sometimes I think like to see a building with bracing in it because it shows them that, hey, we thought about earthquakes, it's a safer building. And a lot of architects can kind of buy into that. Some of them don't. They don't like the idea. They want to keep their clean lines, and that makes our job a lot harder. Well, again, I had a facetious response to, Jamie, you idiot. But there's a lot of reasons. I mean, just because it's almost like, I hear that, and I almost think it's like, well, you've been driving for how many years and you've never been in a wreck? Well, or if you're going on the freeway, are you going to put your seatbelt on? Of course you are, because it's a statistical thing. Earthquakes happen at sort of a random occurrence, but eventually they will happen almost everywhere. And we don't know if the next earthquake is going to be 50 years from now or if it's going to be tomorrow. So we have to just take into account and assume it's going to be tomorrow when we do our work. Also, when you look at earthquakes, the design earthquake, most of our buildings, especially in Seattle, have never undergone that earthquake. We've had some very major earthquakes, but nothing that compares to what could happen, what we know from some of the sources, either off the coast of Washington or around in the crustal zone in Seattle. We could have some very big earthquakes, which would cause tremendous damage, and we've seen in some parts of the world, and even the United States and California, what that disruption and cost can be.